Good evening, this is Blake McHugh. I'm attempting a video reassessment of Standard 2. Our problem is we have a 210 kilogram elevator moving with an upward acceleration of 1.5 meters per second squared. And we need to find the force tension of the support cable. So the first thing we're going to do, which I already have it drawn out, is we're going to draw a force diagram. And right here in the center, that's our 210 kilogram elevator. And pulling downwards, we got our force of gravity. We need to find our force of tension. So after we draw our free body diagram, we draw down everything we know about the problem. We know gravity is equal to negative 9.8 meters per second squared. We know the acceleration of the elevator is 1.5 meters per second squared, and we know the mass of the elevator is 210 kilograms. So first thing we want to do is we want to find force of gravity. We know force of gravity is equal to mass times the pull of gravity, which is going to be negative 9.8 meters per second squared times 210 kilograms. And that leaves us with negative 19,698 newtons. We went to newtons because we're multiplying kilograms times meter per second squared. So that's going to be our force of gravity. Now then, from there, using Newton's second law, we know the net force is equal to the acceleration times the mass. So we know our acceleration, which is 1.5 meters per second squared, and we know our mass, which is 210 kilograms. That gives us a product of 315 newtons, which again, we're multiplying kilograms times meter per second squared, and we're getting newtons. From there, we can determine, since that's the net force, we can add the net force to the absolute value of your force of gravity, and that's going to give us our force of tension, which is what we're after. So we take our 3,015 newtons from our net force, and the absolute value of our force of gravity, which is 19,698 newtons, and we get a sum of 22,713 newtons pulling upwards on the elevator.